As we go through chapter 22 of our book, you're going to see that we're focused on hydrocarbons. And as I come out a little bit here, this is page 696 in your textbook, and you can see an oil pipeline here that really is kind of interesting because that's drawing oil or taking oil across sometimes thousands of miles to where it's going to be refined and actually become gasoline and all kinds of other stuff. Now, if you look over here at the first little section that we're going to be doing, our objectives are to describe the structures of alkanes, which are the simplest of the hydrocarbons. And hydrocarbons are simply hydrogen with carbons. And the alkane structures is what we're going to be learning about, how to describe them, how to name an alkane by examining its structure, and how to go the other way and draw the structure from the given name of the alkane. So we're going to go right to my little tutorial that I have done for you on hydrocarbons, and I want to focus in on what seems to be a fairly complicated hydrocarbon. And as you look at this little guy, you're going to see that there is a chain here somewhere that actually has a 10 carbon long chain. Now, what is a chain? A chain starts from one end carbon, and let me give you an example of where the end carbons would be. There's an end carbon here, there's an end carbon here, an end carbon here, here, and then down at the bottom, here, and here. So there's lots of places that we could start and end up. The thing in figuring out where the longest chain is that you have to go in there and look at this quite carefully and count without going backwards or off in any direction. So, for instance, I might, when I first look at this, especially if I'm inexperienced, I will start maybe over here and I'll count my carbons. 1, 2, 3, 4, 5, 6, 7. But I'm telling you, there's one in here that's 10 long. And so you got to adjust your mind to see this in different ways. For instance, I can count from here as well. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same numbers, huh? Well, I can also go down here. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got a few more. I got one more that way. And I could try it from here. Let's try it going from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Aha! That's where it is. It was hiding, huh? Well, what we do is when we find that longest chain, the first thing you want to do is draw a circle around it. And the reason you want to draw the circle is we name these things by what's stuck on the longest chain. So this being the longest chain, here's 1, 2, 3, 4 different what's called substituents stuck on this longest chain. So now we want to look at it and say, all right, well, why do we number this as number 1 and not use this as number 1? Well, there's a real good reason. We look at the guys that are stuck on the main chain, and those substituents, as I call them, and we see which end of this chain has a substituent closest to the end. So I go in 1, 2, 3 to get to this guy. When I come from this end, I go 1, 2, 3, 4. Aha, that guy is longer away from the end than this guy is from this end. So that's why this is going to be number 1. Now comes the problem of naming it. So we have to know what these little substituents are all about, and let's go look in the book here for just a moment, and I'm going to show you a couple of charts. The first chart I'm going to show you is on page 700, and this is the chart, and as you can see, this is giving you the names of everybody who has anywhere from 1 to 10 carbons in their longest chain. And you can see it starts with methane, ethane, propane, butane. those are called common names. They're not systematic names. But you'll notice they do all end in ANE, which means it stands for hexane. Now, as we go to number 5, and we see pentane, that's a systematic name. Penta for 5, and then we have hexa for 6, hepta for 7, oct for 8, non for 9, and dec for 10. So this would be decane, nonane, octane, heptane, hexane, and pentane. And you can see the greatest number of carbons in that chain. And there's just several ways that we can write these things. And we'll get into that later on. But we want to now go over to see how do we name our substituents. And this little chart, which is just 2 pages over on page 702, shows you how to write these substituents in different ways. Now, like this guy is a methyl. You notice that all of these end with YL. So we have methyl, ethyl, propyl, isopropyl, and butyl. Now these guys are going to match the methane, ethane, propane, all right, and butane. So what that means is this is a 1-carbon substituent, a 2-carbon substituent, 3, and another 3, and then one that is 4. And then you see how it's actually made, and the interesting thing here is that this guy is the hook. In other words, that's where it's hooked on. Now, in the drawings like this, which I call a carbon backbone, we just have the carbons without the hydrogens. So it's easier for us to see what the structure is and how to name it. So let's go back to my example in my tutorial now that we know a little bit about substituents, and let's see if we can tell what the substituents are on this guy. So I have this as a 1-carbon. Now try and think in your mind what that might be. Yeah, that's right, it's methyl. Now I have 3 of them, 1, 2, 3 of them, that have ethyl groups. And the ethyls are 2 of them on 5 and 1 of them on 7. And then the methyl group here is on number 3. So this is a decane, and we name the substituents in alphabetical order. So ethyl is going to come first. So here's the way we name the substituents. When they're both on, when we have 2 of them on the same one, we have to say the number twice. Now I'm just going to say this number, or say this name. I'm not going to write it down for you. This is 5, 5, 7 triethyl. That's the first part of the name. Now methyl comes next. So this guy is 3-methyl. And then we say the base chain, which has 10 in it, so that's decane. Now let's say the whole thing. 5, 5, 7 triethyl, 3-methyl, decane. Now, let's actually go to your homework, and we're going to figure out, or actually